Let's start with TC-SPC lifetime. Begin by mounting the EPL or EP-LED onto the system. The diode slides into place and is secured by the thumb screw from underneath. Plug in the power cable and the start cable and turn the key to power the diode on. In Floricle, in the signal rate window, choose the appropriate source light path. In this case it's TC-SPC diode. In Setup, TC-SPC laser setup, we choose the wavelength we want to use. Pressing the red button on the laser starts the diode pulsing at whichever frequency you select with the red knob. With our sample already loaded, we choose an appropriate emission wavelength. In this case it's 397 nanometers for anthracene, and we select the emission bandwidth to get a good signal. Adjust the ND filter to increase the light level falling on the sample, keeping in mind that we need to keep the stop rate to less than 5% of the start rate. In this case we keep the emission counts to below 50,000 counts per second. To begin the measurement, we go to TAW, Manual, and this brings up the lifetime measurement windows at the right hand side of the screen. In the top window we have parameters carried through from the signal rate window, the excitation and emission parameters we chose there. In the bottom window we can see the start rate and stop rate. We choose the time range we want our decay to be measured over, as well as a number of channels over which that time range is split. Lastly, we can see the stop condition for the TC-SPC measurement. Clicking the New button begins the TC-SPC process. The TC-SPC measurement will continue until the stop condition is met. In this case, it is when the number of counts in the highest channel reaches 10,000 counts. Once the sample decay has been measured, it is now important to measure the instrumental response function, or IRF. Firstly, we reduce the ND filter to 0 to protect the detector, then change the sample to a scattering solution, such as Ludox, and we change the emission wavelength to match the excitation wavelength of the diode. We then click the Add button and check the IRF box, and then increase the ND filter to match the count rate from the sample. Again, click New and the IRF will appear on the decay. This usually takes much less time since the pulse is generally much shorter than the decay. By default, lifetime measurements are rendered on a logarithmic Y scale. In order to fit an exponential lifetime to the decay, we go to Analysis and Reconvolution Fit in the case where you have an IRF, or Analysis and Tail Fit if you make the decay measurement without measuring the IRF. We provide the algorithm with a good starting point, in this case 4 nanoseconds, and click Apply. It runs the algorithm and generates a lifetime and chi-square value. A chi-squared value of between 1 and 1.3 is considered an excellent fit. Moving on to MCS lifetime, or multi-channel scaling, we typically use the microsecond flash lamp. Use the signal rate to choose the appropriate excitation and emission wavelengths and bandwidths, and then go to TAW, Manual. Again, the top window parameters are carried through from the ones you chose in the signal rate window. and the bottom window contains the MCS measurement parameters. Again, choose the correct time range, number of channels, and stop condition, and then press New to begin an MCS measurement. Once the measurement is complete, click Analysis, Tail Fit if your measurement does not contain an IRF, and again enter a starting value for the fitting algorithm. This will yield a lifetime solution as well as a chi-square value to measure the quality of the fit. Again, a value between 1 and 1.3 is excellent.